Hey there, hope everyone's doing good. This video here I'm going to talk about insertion sort in Python. Here is the code. Again, I know a lot of people just want to jump right in here, grab the code, copy and paste it into their editor and bounce, which is fine. So here's the code. You can look in the description of the video. It should be down there. Here is the code on GitHub. You could just click the raw button here and copy and paste it and start playing around with it if you want. But if you want to stick around and hear my explanation of what's going on, then stick around. Sources for this, the code that we just looked at, we got Wikipedia. I've referenced some of their definitions here, but that's really about it. Big O cheat sheet is where I pull the algorithm analysis in terms of the time complexity and the space complexity. And then Visual Go and TopTool visualizers, which really help visualizing what's going on and seeing it in action as opposed to just thinking about it in terms of code. So what is insertion sort? It's a simple sorting algorithm that builds the final sorted array or list one item at a time. It is much less efficient on large lists than more advanced algorithms such as quicksort, heap sort, and merge sort, right? So it's in kind of those beginner level of sorting algorithms: bubble sort, insertion sort, selection sort. The ones that are a little bit easier to implement, but definitely not as efficient. Insertion sort iterates, consuming one input element at each repetition, and grows a sorted output list. At each iteration, insertion sort removes one element from the input data, finds a location it belongs within the sorted list, and inserts it there. It repeats until no input elements remain. Okay, so let's actually see this in action, because until you've actually thought about it and visualized it, this probably doesn't make much sense to you. Here is the sorting algorithm here for insertion sort, the time complexity and the space complexity. This is from Big O cheat sheet. You can see the best case is O to the n. So if I have 10 elements in a list, best case situation is I have to run this, this algorithm basically 10 times. Otherwise, average and worst is n squared, which is very common across most of the sorting algorithms, or at least bubble, insertion, and selection sort, you can see. Obviously, some other ones like merge sort, quick sort are better at that. And then our worst case is O n squared as well. Here's basically your pseudo code. So you create an inner loop and an outer loop. In the outer loop, you're going to start at the second element in the array. So normally we're used to starting at the first index basically in the array. We're not going to do that. We're going to start at the second one. The reason for that is because we assume that the first element in the list is already sorted. It'll make more sense in a second. We're going to store the value we find at I, because that's basically the first unsorted element. I need to store that in a variable. Then I'm going to create an inner loop. I'm going to start at I minus 1. Okay, so 1 to the left of the card, or the thing I'm trying to insert. And I want to iterate down the list, or to the left of the list or array. As I'm iterating down every single index, I'm checking if there's a value greater than the insert value. If it is, I want to move that to the right. If I find a value that's less than the insert value, right, then I know I need to put what I'm inserting to the right of that. So I break out of the loop and I insert the insert value to the right of the list. And I do this until that outer loop reaches the end of the list, and then we're done, list or array. So this is how it actually looks. Okay, this is our starting situation here, starting state. We have I, which is our outer loop here, right? So for I in range, we start at 1. That's why this starts at 1. For I in range 1 to the length of the list, so I is going to iterate over the rest of these elements. We are assuming the value we find at index 0 is already sorted, so that's why this is shaded. That 17 is shaded. We're just going to assume that's already sorted, and it'll make more sense why we're making that assumption here in a second. Our inner loop, right? So we're first going to decrement, or we're going to set j, create a variable j equals I plus 1. So in this case, I is 1. J is I minus 1. So we have I is equal to 1. 1 minus 1 is 0, so j becomes 0. The other thing we need to do before we jump in this inner loop is we need to store the value. So we have this insert value right here. Notice it's the actual value that's in this array slot. It's not the index, right? This is the index 1. That's what I is pointing to. I is pointing to the index. We want the actual value. So we grab that value, we store it in a variable. I call it insert value just because it's a little bit easier to understand when you're first learning here. But you might want to call it something else if you're doing this in production. Okay, then I'm going to iterate down the whole rest of the list. So everything that's basically to the left side of I. Right, so I'm going to start at j, right, which is right here, while j is greater than or equal to 0. And j, when we first start here, remember that's going to be 1 to the left of I. So while j is greater than or less than 0, and the list of j, so whatever I find in my current spot I'm looking for in j, is greater than the insert value. Okay, so if both of these conditions are true, then we're going to push this here, whatever we find at j, to the right, and then we're going to decrement j. And we're going to continue until we find a value less than our insert value, or we reach over here the end of the list. So, starting condition, we got I set to 1. We stored our insert value. We set j is equal to I minus 1, so j becomes 0. When we get here, we say, okay, that value we found at j, which in this case is 17, that's greater than the insert value at 12. So basically, we need to take this value 17 and shift it to the right. Now, we're not going to swap it, okay? A lot of the other algorithms, we've been swapping these. We're not actually going to swap these. So I'm not going to take 12 and put it here and 17 and put it there. I'm just literally going to copy the value here, 17, and throw it in this index. That's how I get here. Now, this note's important, okay? Because we shifted this 17 value to the right, the value found at j to the right, we've overridden the index where this insert value originally was. That is why we have to store this value, whatever value we find at I, in a variable. This is why we have to do this line right here. Because if I don't store it in a variable, I'm going to completely lose access to it once I shift anything into that I index. Next up, okay, so now j has reached the end of the list. So we're hitting this condition here in our while loop. J is no longer greater than or equal to 0 because it's -1. So we're going to exit, we're going to break out of this while loop. And then the last thing we're going to do is this down here. We're going to take the list, right, or the array, right? We're going to find the index j plus 1. In this case, j is -1. You add 1 to that, you get index 0, which is this index in the array. And we're going to put our insert value in there, in that index. So our insert value 12 gets copied into here. And now we have 12 and 17. So let's keep going. J's reached the end of the list, so basically now we're going to break out of this inner loop. We've done that, and now we're going to start the next iteration of our outer loop right here. So our next iteration. I becomes 2, or excuse me, yeah, I becomes 2. J becomes I minus 1, or 1. We copy the value at that I index into a variable called insert value, so that's 37. And then we start this inner loop again. All right, now in this inner loop, we get to a situation right here, right? The list j, which is 17, is less than Sorry about that. I thought I had someone knocking. So the list J is actually less than the insert value. So this condition right here is false, right? The list J is not greater than the insert value. So in this case, we're going to instantly break out of this while loop. Well, we broke out of the while loop. And let me go back up here. We broke out of the while loop, so we still have this line right here. So I'm going to say the list J plus 1, J being J being 1, you add 1 to that, you get index 2. In this case, we're already pointing there, so it's fine, but we would copy our insert value in there. It's already there, so no big deal. But, however, we are going to just consider that sorted now. All right, so now we go up and we do our next iteration of the outer loop. Okay, right here, here's our outer loop. I becomes 3, J becomes 2. We create a variable for whatever we find at the I index, which is insert value becomes 19. And we start the whole process again. Okay, because what we find at J is less than the insert value, you're going to shift that 37 to the right, decrement J from 2 to 1, and continue. So notice we have 37 in both slots right now. That's fine. Finally, we get to a value 17 here that is not greater than the insert value. So this condition evaluates to false. So we break out of this inner loop. So that's inner loop's done. We still have this line here to do, the list of J plus 1. J plus 1 is 2. So that's this index here. So we copy our insert value into that index. Okay, and we consider that sorted. So now we start our outer loop again. And we only have one element left here. Insert value is 20, I is 4, J is 3. 37 is going to be greater than 20, so we're going to copy 37 to the right there. It's J plus 1. And we're going to decrement J. J is now 2. We find a value 19 that is less than our insert value, so we know our insert value needs to go to the right. So we throw 20 to the right of 19, start our outer loop again. In this case, I has reached the end of our list, so our loop exits and we are completely sorted. Let's look at it in Visual Go here. I already have it open. And we will see a better explanation of it. So I'm going to hit play here. This is the same array, the same list that I just used in that slideshow presentation. So we're starting at 17. Again, look right here, mark the first element 17 as sorted. That's why you start at index 1, not index 0. We just assume right from the get-go the 0 element there, or the 0 index, the first element is sorted. Okay, now this shows us pulling this actual value out. We're not really pulling the value out, we're storing it as a variable. But essentially you pull it out, you store it as a variable. Our insert value is 12. We compare it. We notice 17 is greater than 12, so we shift 17 to the right. And then we insert 12. Now we know 12 and 17 are sorted, so we're going to start here. That's where our outer loop's going to go. We're going to put this into memory, store it as a variable, 37. And then I'm going to compare it against 17. Well, 17 is less than 37, so we're just basically going to throw this 37 back into place there. Now we're back at our outer loop. We save the value 19. That's the insert value. We're going to compare it against 37. It's less than 37, so we're going to shift 37 to the right. Now we're going to take that 19. We're going to compare it against 17. 17 is less than 19, so we know 19 belongs to the right of 17, so we're going to put it in there. All right. Starting our outer loop again, we store 20 as our insert value. We compare it against 37. We know 37 is greater than 20, so we shift 37 to the right. And now we check 20 against 19. And we know 20 is greater than 19, so it must go to the left. or excuse me, you must go to the right. So we insert 20 there and we're sorted. All right, and let's just watch this fast one more time. Okay, and let's see this on a completely random 10 element or so, whatever this is, list. So this is very similar to how most people will organize their playing cards in their hand. You're playing a game of poker or something, and you're dealt a bunch of cards. Most people will organize them very similar to this setup. All right. Now, finally, before I get into the code, let's see how this sorting algorithm compares against kind of the other ones. Here's top tal. Top axis is all my different sorting algorithms. Left axis is different starting states for the list, so a completely random list or array, a nearly sorted list or array, all here. A completely reversed, so sorted in the wrong order, array, and then array with few unique values. So here is selection sort. Let's see, no, we're doing insertion sort. So here's insertion sort on a completely random one. Here is it on a nearly sorted one. You can see it was fast, so let's do that again. I'll hit play all and just watch how insertion sort stands up against the rest of these sorting algorithms. Okay, you can see it's not too bad. Bubble sort, selection sort, not so good. Obviously shell, merge, heap, the rest of these are going to be very fast because they're more advanced sorting algorithms. But in this case, insertion sort isn't too bad. Pretty easy to implement too. Alright, so now let's go into the actual coding portion. So let me bring up PyCharm here. And let's see, first off, I'm going to just create a function called, and let me get rid of my project tree there, and I'll increase my font. So let's create a function called insertion sort. What does it take? It takes some type of list, and again, you can change your variable names to whatever you want. We need our outer loop. So for I in range, and remember, our outer loop is not going to start at 0 like you're probably used to. It's going to start at 1. Because remember, we always assume that the 0 index in that array is already sorted. For I in range, I need an in. For I in range, start at index 1, go for the entire list. Now we need to take the insert value, because remember, we need to copy whatever value is, let's go back here for our starting state. We need to copy whatever value. Here's I is 1. We need to copy whatever value is at that index to a variable. Because remember, as we shift these things to the right, we're going to lose that. We're going to lose access basically to this value that's stored there if we don't have it as a variable. So insert value is going to be equal to whatever is in the list at index I. Now I need to say, okay, well, remember J is right here. It's 1 less than I. So J is going to equal to I minus 1. Next up, we need our inner loop. I'm going to use a while loop for this because I don't know exactly when it's supposed to end. Normally, if you have a set exit condition, you know exactly how many times your loop is going to iterate. You'll use a for loop. In other situations where you're not sure how many times it's going to run, you use a while loop. You don't have to, you can do it both ways. But I'm going to use a while loop. And my conditions here are going to be while J is greater than or equal to 0. Because, right, if J gets over here outside of the list, if it becomes negative, then I know this inner loop has reached the left side of the list and I need to stop. So while j is greater than or equal to 0, and, okay, both of these conditions have to be true, whatever we find at j, so the list j, whatever we find at that index, is greater than whatever we're trying to insert. Then what we're going to do, so just like right here, right, this is greater, 17 is greater than what I'm trying to insert, and in this first loop, j is equal to 0, so it's so both these conditions will be fine. So while j is greater than or equal to 0, and whatever we find at the list, so the list index j is greater than the insert value, I need to move whatever I find there at the list of j to the right one. Right? Remember, I need to copy this 17 and move it to the right one because it's greater than that insert value. So I'm going to say the list j plus 1 is equal to the list j. Right? All I'm doing is I'm taking whatever's at j and I'm also putting it to the right one. That's it. Now what I'm going to do is I'm going to say j minus equals 1. I'm going to decrement j, right? Because once I've moved that thing to the right one, I need to decrement j. Otherwise, if I forget this line, we're never going to break out of this loop. I'm never going to get to a situation where j is greater than or equal to, or where j is less than or equal to 1, 0 there. Where j is negative, that's what I'm trying to say. All right, so next up, what are we going to do? That's really all we need in this inner loop. The last thing we're going to do in the outer loop, right? So before I completely break out of this outer loop is I need to take what is at the list of j plus 1, and I need to assign that or put the insert value in there. Okay? Because remember, when I get to the end here, j is going to be in this case over here, minus 1. So we need to say j plus 1, which is 0, and we're going to throw our insert value 12 up in there. Okay, and then finally, I need to return the list, return our sorted list. So let's try it. I got some test cases already printed out here. So this is the unsorted list, the same exact one that we used in the slide presentation there. And throw it in the insertion sort, and we'll see what I get back. Let me run this. See if I can make that bigger for you. Make this a bit bigger. All right, so there we go. Here's my unsorted list, and when it's done, it's sorted 12, 17, 19, 20, 37. I like to always do a few different type of test cases, so let's throw some negatives in there. So test case 2, I got 5 elements, including negative numbers, -5, 100, 3200 something, 10, 2500 something. So let's test that. And on that second test, I get -100, -5, 10, 2532, and 3245. So I would say our algorithm works with negative numbers as well. One edge case I always like to consider is what happens if I throw an empty list at it. Make sure I don't get any random exceptions or errors, index out of bounds errors or anything, okay? So even if I throw an empty list at it, it returns an empty list, which is good. That's what I want. And finally, I need to import random up at the top here. And let's go ahead and throw another test case, a random list of 20 elements here. Whatever Python decides to give me is a random list. So here's the random list they gave me. Let me reduce my font size a little bit to make it all fit in one line. Here's the random list they gave me, and it looks like it's all sorted correctly. So I would say that's a good test. I could run this multiple times. Each time checking to make sure that whatever I get over here looks sorted, it does. And I could write some more advanced unit tests to ensure that it's sorted. But I would say that we got a pretty good implementation here. Here's the actual code. Remember, you can get it in GitHub. Yeah, and that's it. That's Insertion Sort. So if you got any value out of this video, please like, please subscribe, and just drop me a comment. So I appreciate it. And yeah, look for other sorting algorithms here in the future. Thanks.